Okay, so we're looking at energy flow diagrams now. So if we have a look at this diagram, okay, so we're starting with the battery, which has got chemical energy, and basically we're looking at an iPod or an iPhone or an something. So we start off with your chemical energy. Once it's connected up and in your phone or whatever, so obviously a battery like this is not in one of those phones, but you know what I mean by battery. Then that energy gets, that chemical energy or potential energy, chemical potential energy goes into electrical energy. That goes into kinetic energy, and which is your speaker vibrating, okay? And from there, that vibration of the speaker causes sound waves, the particles in the air, and it transfers through, it goes into our ear, and that's our sound energy. So these arrows going to a particular name is called a type of energy, is called an energy flow diagram. If we look at this one, we've got kinetic energy here of the wind or the wind energy. That kinetic energy is turning this and spinning it. So you've got the kinetic energy of the air particles, and we often call that wind energy, but anyway. And this is starts spinning that. So that's, once it's moving, it's called kinetic energy. That spins a little like turbine in here, so there's kinetic energy in there. That spinning of wires and around a magnet causes electrical energy, so we get electrical energy in the wire. That turns our light bulb on, so from there we're getting light energy and we're getting heat energy. So if you touch a light bulb, it will be heat, and a lot of the energy is mainly heat energy. Light bulbs are very inefficient. So our energy flow diagram would look like this. So we have our wind energy, kinetic energy in here, electrical energy here, and then that's going into light and heat energy. So we can have it actually splitting off like that as well. If we look at this, we've got your kinetic energy of the air, spins the turbines, which is, well, spins the big propellers, which is obviously kinetic energy because they're moving. That spinning there goes into your turbine, it spins that, which is movement, so kinetic energy, and then all that spinning in there turns it into electrical energy, so we get electrical energy in the wires. We can look at the same output of electrical energy, but can come from a different way. So we've got dams, and the water is at a high level, which is called potential energy. As they open up these gates here, it falls down. So it's going from potential energy turning into kinetic energy of the water. So as it goes through, it actually spins turbines again. So we've got a turbine in here, turbine in here. That spinning of a turbine, which has got magnets and wires, turns it into electrical energy. We can also get a different output from coal energy. So we have our energy of coal, which is a chemical energy. So they've probably written this one wrong here in this diagram. So the coal has got some chemical energy in there, and then it's burnt. So we've got chemical energy in here as well. So it boils water. So that's where we get the kinetic energy of the steam. So you've got some thermal energy first of all, because it and then you've got this going, so you've got thermal energy, which is called kinetic energy of the steam. That steam turns turbines, so we get kinetic energy again as that's spinning around, and it's the steam that actually spins these around. Once the turbines are spinning, we get electrical energy. So we have to remember the order is important when drawing an energy flow diagram. Just a simple, clear statement of the type of energy, an arrow representing its transformation onto the next form. Some energy flow diagrams may be circular, but only under special circumstances. There you go.